All right, let's dive right in. Today, we're going to look at the beautiful, powerful models we've built to understand reality. And then we're going to find the cracks, the deep, fascinating fractures that are starting to appear in our most basic understanding of everything. This is where things get really interesting.
You know, we start from this place of incredible confidence. And for good reason. For centuries, we've been on this amazing quest to map the cosmos, asking the biggest possible questions. And honestly, we've come up with some absolutely mind-blowing answers.
But here's the kicker. What if the very foundations of those answers are, well, a little shaky? What if our most successful theories are starting to contradict themselves? That's exactly what we're digging into today. The weak spots, the places where our neat and tidy picture of reality starts to fall apart.
So first, let's get our feet on the ground with the standard model. This is the universe you learned about in school, right? A picture that's been built on just mountains of evidence. But even within this accepted model, there are some huge, gaping holes.
And the biggest hole has a name: dark matter. We know something massive is out there, something huge, because we can see its gravity pulling on all the stars and galaxies we can see. It's kind of like feeling the wind on your face but not being able to see the air itself. This invisible stuff makes up most of the matter in the universe, and we have basically no clue what it is.
So how in the world do you see something that's completely invisible? Well, astronomers came up with this brilliant trick called gravitational lensing. Einstein figured out that really massive objects literally warp the fabric of spacetime, and that means they also bend the path of light. So by looking at how the light from a super distant galaxy gets stretched and distorted, we can actually map out the invisible blob of dark matter that's sitting in front of it. It's like using the universe as a giant funhouse mirror to reveal a hidden reality.
And this leads us to the first really deep crack in what we know. We have these two absolute pillars of modern physics. On one hand, you've got Einstein's general relativity. It perfectly describes the big stuff: planets, galaxies, black holes. Then you have quantum physics, which is just unbelievably accurate at describing the tiny world of atoms and particles. Both theories are spectacularly successful. The problem? When you try to use them in the same place, like at the very center of a black hole or the instant of the Big Bang, the math just completely falls apart. They spit out nonsense. Our two best descriptions of reality just don't work together.
Now that's not just some nerdy math problem. It's a crack that goes all the way to the bottom. It makes us question the very stage on which this whole cosmic drama unfolds, space-time itself.
For about 100 years, we've just assumed that space-time is the fundamental grid of reality. You know, it's the box that holds everything else. But there's this wild new idea picking up steam. What if space-time isn't a floor? What if it's more like the temperature in a room, an emergent property that arises from the interactions of something much, much deeper and more fundamental at the quantum level?
And this isn't just one fringe idea. It's bubbling up from a few different places. Some physicists think the universe might be a kind of quantum liquid, and space-time is just how it flows. Others propose the holographic principle, that our entire 3D reality is actually a projection, like a hologram beamed from a flat 2D surface at the edge of the universe. And then there's loop quantum gravity, which says space-time isn't smooth at all, but is actually pixelated, made of these tiny, indivisible chunks. All of these point to the same, frankly mind-bending conclusion. What we think of as solid reality might be an illusion.
Okay, so the actual fabric of the universe might not be what we thought. Wild. But what about us? You know, the people doing all this thinking. Let's pull back from the edge of the cosmos and zoom right into our own heads.
Right now, the most popular way to think about the brain, especially in AI, is that the mind is like software. Your consciousness is just a program. And in theory, you could run it on any computer that's powerful enough. A brain, a silicon chip, whatever. But there's a really compelling counterargument that says, not so fast. Maybe consciousness isn't just code. Maybe it fundamentally depends on the unique, wet, messy biological stuff of life itself.
So what's so special about biology? Well, one clue is this weird property called homochirality. Sounds complicated, but it's simple. All the key molecules that make you, have a specific handedness. They all twist in the same direction. Your amino acids are all left-handed, and your sugars are all right-handed. This isn't random. It's a universal signature of every living thing we've ever found on Earth.
And that uniform twist might be the whole ballgame. It poses a huge problem for that mind is software idea. See, this structure allows biological molecules to do some really nifty things with quantum mechanics, even in a warm, messy brain, things that our silicon computers really struggle with.
So your consciousness might not be some algorithm you can just copy and upload. It might be deeply tied to the specific quantum magic that only biology can perform.
Okay, we've questioned physical reality. We've questioned the nature of our own minds. So for our last trick, let's question the very system of logic we're using to have this conversation in the first place. Let's talk about the scientific method.
Modern science is built on the rock of rationalism, this method of systematic doubt pioneered by René Descartes. But where did he get this idea? Well, history's pretty clear about it. It came to him in a series of 3 incredibly intense, vivid dreams. He didn't describe it as a logical breakthrough. He called it a state of enthusiasm, a kind of direct, mystical revelation that gave him the unshakable certainty he needed to build a whole system based on doubting everything else. And the impact of this vision? It was explosive. Seriously. Historical analysis shows that after these dreams, Descartes' rate of innovation, his original contributions to science, shot up by an absolutely staggering 340%. This wasn't just a good idea. It was like a creative bomb went off in his head.
And he's not alone. Think about Isaac Newton. We all learn about his work on gravity, right? But the man wrote way, way more about alchemy, theology, and mysticism. In fact, if you compare the volume of his mystical writings to his scientific ones, the ratio is 282 to 1. There's this clear pattern where our scientific culture just sort of edits out the irrational, mystical origins of its biggest breakthroughs.
And that brings us to this deep, profound paradox. The very system of rationalism, which demands objective, repeatable proof for everything, was born from a completely subjective, mystical experience that the system itself would have to reject as invalid. Our model for understanding the world is built on a foundation that it literally cannot explain or accept.
So we've got these cracks in our view of the cosmos, cracks in our idea of the self, and this massive crack in the very foundation of how we know things. When you start to pull on all these threads at once, well, you get what feels like a great unraveling. The philosopher Terence McKenna had a really interesting way of looking at this. He suggested that modern technologies, like the internet, basically act to dissolve boundaries. The old world was defined by print. It was linear. It put things in nice, neat boxes. But our new electronic networked world blurs all those lines, bringing back a much more fluid, interconnected way of seeing everything.
And when you look at all these challenges we've talked about, they stop seeming like separate problems. They start to feel like the tremors before a huge earthquake, a massive paradigm shift. The cracks in physics, in biology, and our theory of knowledge, they're all pointing towards one thing, a massive acceleration into something completely new.
All those hard lines that we used to use to make sense of the world, they're getting soft. They're becoming permeable. Is the universe just information? Is the mind just biology? Is science just reason? The answer to all of these questions is getting blurrier by the day. The line between the universe and the mind, between the machine and the organism, between the rational and the mystical, it's all dissolving. And this whole process seems to be speeding up. Like McKenna said, the universe has always been getting more complex. But now, that process is happening so fast, we can actually see it, feel it, within our own lifetimes. We are living on an exponential curve of change, and it's getting steeper.
So all of this leaves us with one last massive question. The old maps are being torn up. The ground is shifting under our feet. As these old ways of seeing the world collapse, the responsibility and the incredible opportunity falls to us. The question isn't just, what is reality anymore? It's what new reality are we going to create?